My Little Quadratics book. This book belongs to. Please write your name on the front cover. Once you open the book, you'll find your table of contents. Use this for reference. Page 1. Parts of a quadratic in standard form. This equation right here is a quadratic equation in standard form. Now the parts of this equation is the a, the b, and the c are coefficients. Specifically, a is the leading coefficient, b is the composed coefficient, and c is the constant coefficient. Now this ax squared is your leading term, bx is your composed term, and c is your constant term, also known as your last term. F of x, we can also say it's y. Now, this side of the equation is an expression. One side of an equation is an expression, while the whole entire thing is the equation, or function also in this case. This squared right here, this 2, is a degree, specifically the leading degree. It's the highest exponent. So this is a degree 2 function. The equal sign is the relation sign. On the next page, you'll find some vocabulary words, and you need to write the definitions down. Pause the video and define the terms that you need to. Page 3. This is the box method. We have two binomials being multiplied together. One way we can show our work to find the answer is to do the box method. So we take our first binomial, 3x plus 1, and put it on the side of the square. And then we take our other binomial, x minus 2, and we put it along the top of the box. From here, we're going to multiply. 3x times x is 3xx, which is 3x to the second power. 3x times negative 2 is negative 6x. X times 1 is a plus 1x. And 1 times negative 2 is a minus 2. Now we want to combine the diagonal. So we have negative 6x plus 1x. That's negative 5x. So we have 3x squared minus 5x minus 2. And this is our standard form. We started with factored form, and then we went to standard form. On the next page, we're going to also multiply two binomials together, but we're going to use what's called the FOIL method. FOIL is, the F stands for first. That means the first term in each binomial will be multiplied together. So we have 5x times x. That equals 5x squared. It's two x's. O stands for outer. We take the outer terms and multiply them together. So we have 5x times 1. That equals plus 5x. I stands for inner. We multiply the inner two terms that are in each binomial. So negative 7 times x. That equals negative 7x. And then L stands for last. We multiply the last terms together. Negative 7 times 1. That just equals minus 7. We combine the two middle terms, the outer and the inner, to get negative 2x. Put them together. So we have 5x squared minus 2x minus 7. And that is our standard form. We started with factored form, and then we went to standard. Next, let's talk about page 5, factoring methods. First, we're going to talk about the cake method. So we're going from standard to factored here. So for the cake method, we want to divide out our greatest common factor. If you can't find it right away, just pull out any prime number you can. 2, 3, 5, 7, etc. It looks like both of these terms could go, like 3 could go to both of those, so let's divide each term by 3. 6x squared divided by 3 is 2x squared. Negative 3x divided by 3 is negative 1x. From here, we can also pull out an x because both terms have the letter x. If we divide those out, we get 2x minus 1. So this is our leftovers. It goes on the inside of the parentheses. This is our greatest common factor. It goes on the outside. So we have 3x on the outside, parentheses, 2x minus 1. And that's our factored form. Let's talk about a different method. What if we have 3 terms and we can't take out a greatest common factor? Well, what we want to do is identify A, B, and C. If you remember from page 1, A is in front of x squared. There's nothing in front of x squared, so that means there's only one of those. 1A. A is 1. B is what's in front of the x value. That's a minus 5. And C is the constant without the letter, plus 6. In this box, we want to write A times C. That's 6. In the bottom box, we will write B, negative 5. In the two side boxes, we want to find two factors that multiply to give you the top number 6, and they add to give you the bottom number negative 5. So let's first write all the factor pairs of 6. We have 1 times 6, 2 times 6, no, 2 times 3. We already have 3, so we're done. Once we get to the next number right here being one of these numbers, we know we're done. Now we notice that this is a negative and this is a positive. That means that we're going to add these numbers together, but they have to be negative because our sum is negative. So we have negative 7, negative 5. We will use the second one because that gives us the sum that we want. So from here we put parentheses. From there we write x, x, and then we put minus 3 and minus 2. And that's it. That's our factored form. On page 6, we're going to talk about a different method of factoring. It's called slide and divide. So what we want to do first is slide that 9 over and multiply it. So we have x squared plus 15x plus 36. From here, we want to find two numbers that multiply to 36 and their sum is 15. So let's write all the factor pairs of 36. We have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 and, if you divide 36 by 5, you get a decimal, so that's not a factor. And then we have 6 and 6. This is adding, this is adding. So that means they're the same sign and they're positive. So C sign tells us if it's the same sign or different signs, and the B sign tells us if it's positive or negative. The same sign and they're positive, so we're just going to put plus signs right here. Let's find the sums of each of these and see which one gives us a positive 15. After we fill out the table, notice that the 12 and the 3 are the ones that work. So we write our parentheses. We put x, x, put plus 12 plus 3. So remember we need to do slide and divide. We've only done the slide part. We have to do the divide part. So we multiplied the 9 at the beginning. So now we have to take it back out. So we're going to divide these by 9. From here, we're going to simplify the fractions as much as we can. So that means what we have, x plus 4/3 and x plus 1/3. Now, from here, we don't want to have fractions in our factored form. That's not the proper form that we want. So we're going to slide the denominators to the front of x. So our factored form will be 3x plus 4, parentheses, 3x plus 1. And that is our factored form. Okay, let's talk about yet another way to factor from standard to factored form. So first, we always check to see if we could take out a greatest common factor. In this case, we could take out a 2 because all of these coefficients are even. So 3x squared plus 4x plus 1. Let's factor this further from here. We want to find two numbers that multiply to 3 and they add to 4. 1 and 3 are only factors, so that's what we're going to decompose it into. So we have 3x squared plus 3x plus 1x plus 1. We're going to group these, and we're going to group these and factor our greatest common factors. The greatest common factor of 3x squared and 3x is 3x. When you divide it out, you should get x plus 1. Our greatest common factor of x and 1 is only 1. So if we factor out the greatest common factor of these two terms, it's x plus 1. So we take out x plus 1 and put it on the outside. What's left on the inside is the 3x and the plus 1. And as an exercise, if you want to try the other methods from the previous page, you may do so. You'll get the same answer. Okay, let's look at this one. We have 4 terms here. So let's factor out these two and these two. Let's change this to a plus since we have a minus out here. So the greatest common factor of 2x cubed and 3x squared is x to the second power. If we divide 2x cubed by x squared, we get 2x. Divide these and we get plus 3. Okay? The greatest common factor of 8x and 12 is going to be 4. 8x divided by 4 is 2x. 12 divided by 4 is 3. This is what we want. So we want the parenthesis items to be the same. If they're not, you probably didn't factor out the GCF, or it might possibly not be factorable. The greatest common factor here between these two terms is 2x plus 3. So let's pull that out. 2x plus 3, and then on the inside what's left in the parentheses is x squared minus 4. And that's our factored form. If you want to factor even further, x squared minus 4 is the same thing as x plus 2 and x minus 2. And this is a pattern that you can use a formula for that we'll talk about later in this video. Specifically on page 13. Page 8, standard to factored X box. So this is a lot like page 5, except for now A is not 1, it's another number. So if you're more comfortable with one of the other methods like slide and divide or grouping, you may do that after these notes. But for the video and for this page, go ahead and do this method anyway. So we have 2 is A, 5 is B, and -7 is C. A times C is -14. B is 5. We will find two numbers that add to 5 and they multiply to -14. Since -14 is negative, the product is going to have different signs. Since 5 is positive, the sum is going to be positive. So that means the bigger sign is going to be positive and the smaller sign is going to be negative. Let's write our factors. 1 and 14 and 2 and 7. We'll use 7 and -2 because that's the one that gives us the +5 sum that we want. From here, we're going to write the numbers on the inside of the box. So it's like reverse box method. So we write the first term here, 2x squared. First term just comes from what you're originally given here. The last term is -7, and the two middle terms is going to be plus 7x and -2x. Let's pull out the greatest common factor out of each of these. The greatest common factor of 2x squared and 7x is x. The greatest common factor of 2x squared and -2x is 2x. For these two, it would be -1. And then for 7x and -7, that would be +7. So that would be our factored form. Parentheses 2x plus 7 and x minus 1. And that is our factored form. Oh yes, also on the, page 7, make sure you put a 2 on the front of your factors. Page 9, finding roots. To find the roots, you set f of x equal to 0 or y equal to 0 to solve for x. If it's already factored, you just set each binomial equal to 0 to solve for x for each. After you've written both of your equations, solve for x on each one. 7x equals -1, divide by 7. X equals -1/7. Add 5. X also could equal +5. So those are your two roots. Now, what if it needs factoring? Let's do our x factor method. So we multiply 2 and 1. Find two numbers that multiply to give you 2 and they add to give you 3. That would just be 2 and 1. They're both positive. Now you're in the factored form again, so you set each of the binomials equal to 0 separately with your 0 property. And if you solve for x on both of these, you get x equals -2 and -1. Okay, how about the quadratic formula? That's on page 10. So the quadratic formula is for those cases where it's not necessarily factorable, but you want an exact answer with square roots. The formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Let's solve. A is 1, b is -14, and c is 13. Make sure that it's in the equals 0 form first. If it's not, you need to make it into that form before you do anything else. So from here, we're going to plug it into the quadratic formula. X equals negative 14 plus or minus the square root. Negative 14 squared minus 4 times 1 times 13, all over 2 times 1. Now make sure when you're first plugging it in, you plug it in exactly like the equation has. Make sure you put the parentheses and everything. If it wasn't for these parentheses, you might not remember that there's 2 negatives here, which makes it a positive. So after you simplify it a little bit, change negatives to a positive, multiply, you should get x equals positive 14 plus or minus the square root of 196 minus 52 all over 2. Let's subtract 196 from 52 to get 144. We know that the square root of 144 is 12. So we basically have x equals 14 plus or minus 12 all over 2. That basically means 14 plus 12 divided by 2 and 14 minus 12 divided by 2. If you plug both of those in, you get x equals 1 and 13. At the bottom of this page, we have something that's called discriminant. The part with the square root is called the discriminant. There's 3 possible cases you could get. If this number is less than 0, you'll only have 2 imaginary roots. That basically means no real solution. So they're all extraneous here. There's no solution that is real. Now, if you get something that equals 0, then that means that you have 2 repeated real solutions. And if you have something that is greater than 0, that means that you have 2 unique solutions. So what is this useful for? Since you can use a calculator in this Algebra 1 course, the main thing that this would be useful for is knowing how to plug in a formula, and also you'll keep these notes and they can help you on other tests coming up later, such as the PSAT, SAT, and Algebra 2 stuff. Let's go on to page 11. We're completing the square. So for completing the square, we want to first put the C on the other side. We will move C to the other side. The next step, which is not needed in this case, is to divide everything by A, if A is not 1. A is 1 in this case, so we can skip that step. Now, step 3, you want to find B over 2 squared. So we know that B is 14, so that means that 14 over 2 squared is 7 squared, and that's 49. We're going to add that to both sides. So we add 49 right here and plus 49 right here. We go ahead and add 51 plus 49. That gives us 100. then that's what we want. We want perfect squares. We're completing the square. So we have x squared plus 14x plus 49 equals 100. This trinomial here is a special trinomial that is known as a perfect square trinomial. What that means is that we have x plus 7 and x plus 7 again. 7 times 7 is 49, and 7 plus 7 is 14, so that works. So if we rewrite that, we can write it like this. X plus 7 squared equals 100. To get rid of a square, we take the square root. That cancels those. X plus 7 equals plus or minus 10. Whenever we take a square root of a constant like this, we're going to put a plus or minus in front of it. So from here, we have two different equations. We have x plus 7 equals 10, and x plus 7 equals negative 10. If you solve both of these, we get x equals 3 and x equals negative 17. Page 12. Solving for roots with a calculator. Here's where we get to learn the shortcut on doing these factorings. We have 3n squared minus 31n plus 70. What you want to do is go to Calculate, Menu, 333. So we go to our calculator, go Calculate, Menu, 333. So Menu, 3 Algebra, 3 Polynomial Tools, 3 Complex Roots of Polynomial. Next, what you want to do is type in this expression. Now, make sure if it has an equal 0 or something, or has an equal sign, make sure you do not put that. And make sure that A, B, and C's terms are all on one side. So let's go ahead and write that in the calculator. 3n squared minus 31n, and then plus 70. And then we put comma n. You'll put comma n and not x because we used n in this expression. You could use x if you'd rather do that instead though. Press enter. These are your two solutions, 10 over 3 and 7. So we'll write that 10 over 3 and 7. So don't forget the comma n. So from here we have our zeros, but to get our factors, we put n and n. And instead of a 10 over 3, we put minus 10 over 3. And instead of a plus 7, we put minus 7. Now, if you recall from the slide and divide method from up here, we can't have fractions in our factored form. So we have to slide that over to the front. So our factored form would be 3n minus 10 parentheses n minus 7. And that is our factored form. Page 13 is all about special factoring formulas. We have difference of squares, sum of squares, difference of cubes, sum of cubes, perfect square trinomials, and the binomial theorem. Now the ones that you'll use the most is definitely difference of squares. You can also use perfect square trinomials, but you could also factor using any of the other methods and it would work the same. So go ahead and pause the video and write these down. The binomial theorem basically is stating a pattern that would happen with any degree, not just 2 or 3. While you're copying down formulas, let's go ahead and also write down our squares and cubes. You should know all of these by memory, but if you don't, you can use a calculator. Try to see how many of these you can do by yourself. Pause the video and then check. Remember, square just means that number times itself. So like 3 squared would be 3 times 3. Okay, here are your perfect squares and cubes. These are the ones that come up most commonly. If you haven't already, make some flashcards and review these. You should be able to find them pretty quickly without a calculator. GCF and LCM. That's page 15. Let's factor this out with just the GCF. Let's use the cake method. They have no x's in common, but you could take out a 2. 24x squared divided by 2 is 12x squared. And 30x divided by 2 is 15x. 8 divided by 2 is 4. There's nothing else you could take out that's a GCF. So that's it. Okay, let's do the next one. 51 and 6. You could take out a 3. 51x to the 7th divided by 3 is 17x to the 7th. Negative 6x squared divided by 3 is 2x squared. Now, they both also have x's, so you could take out x's. You take out 2 of them, because a smaller degree has a 2. So we have 17x to the 5th power. It's 5 because 7 minus 2 is 5, minus 2. So our greatest common factor is 3x squared, so that goes on the outside. And what goes on the inside is 17x to the 5th minus 2. That's our factored form. Let's find the least common multiple of 18x and 4. Now we do the same cake method thing. We divide out 2, and we get 9x and 2. Now instead of having this and this is a GCF, and to get the LCM, it's going to be this. So it's going to be 2 times 2 times 9x. So our LCM would be 36x. Page 16, we're simplifying radicals. The numbers you want to divide out are our perfect squares. Perfect squares that we want to factor out are -1, 4, 9, 25, and 49. Although there's an infinite amount of perfect squares, almost all the questions will always ask using only these squares. So let's go ahead and do this using the cake method. Square root of 8. There's no negative, so we don't factor out -1. Can we do 4? Yes. So let's divide by the square root of 4. 8 divided by 4 is 2. There's nothing else you can factor out of the 2, so that's your leftovers. Square root of 4 equals 2, so our answer is 2 times the square root of 2. This goes on the outside, this goes on the inside. This goes on the outside of the radical sign, this number goes on the inside. Let's look at the next one. Square root of 700. There's no negative. So let's look at the next one. Can we take out 4? Yes, we could take out square root of 4. 700 divided by 4 is 175. That's an odd number, so we definitely can't take out any more 4s. How about 9? No. 25. Yes. So 175 divided by 25 is 7. Can't take out a perfect square out of 7, so we're done with that. Square root of 4 is 2. Square root of 25 is 5. So our answer is going to be 2 times 5 times the square root of 7. 2 times 5 is 10. So our answer is 10 square root 7. Look at this next one. We have a cube root of 16. Now, we're not looking at perfect squares for this one. We're going to look at perfect cubes. So the numbers you want to pull out here is either -1, 8, 27, 125, or 343. Well, 16 is not negative. We can take out 8 though. So take out the cube root of 8. 16 divided by 8 is 2. Can't take out any cubes out of the 2. And the cube root of 8 is 2 because 2 times 2 times 2 is 8. So our simplified form is 2 cube root of 2. Let's look at the square root of 18. We're back to square roots, so we can look at these numbers. It's not negative. Can't take out a 4. We take out a 9. 18 divided by 9 is 2. Square root of 9 is 3. So our simplified radical is 3 square root 2. Square root of 48. It's not negative. We take out 4. 48 divided by 4 is 12. We could take out another 4. 12 divided by 4 is 3. So we have 2 times the square root of 3. That's 4 square root 3. And let's look at the square root of -4. This one we can take out a -1. 4. The square root of 4, we know that it is 2. The square root of -1 is an imaginary number that we call I. So the answer is 2I. Simplify. 5 square root 8 minus 13 square root 18 plus the cube root of 16. Using these worked out examples from above, let's go ahead and fill those in. As of right now, we can't add these terms together because they do not have the same radical. So we have 5 parentheses 2 square root of 2 minus 13 parentheses 3 square root of 2 plus 2 cube root 2. We still can't add that cube root because we can't add cube roots with square roots. But we can add these two together now. Let's multiply them and combine them. So I have 10 square root 2 minus 39 square root 2 plus 2 cube root 2. So if you simplify that out, you would get -29 square root 2 plus 2 cube root of 2. Let's talk more about when we had that square root of a negative number. Those are complex numbers. They're real and there's real parts and imaginary parts. Basically, a real number, that's the symbol for all real numbers. It could be any number that is rational or irrational. These could include rational numbers, irrationals, and then the rational numbers can include integers, whole numbers, natural numbers. All of those are real numbers. Now, imaginary numbers is stuff we have like negative inside of a radical. You have the letter I. It's when stuff that you put in the calculator is undefined. So here's our givens. I to the 0 power is 1. Anything to the 0 power is 1. Almost anything to the 0 power is 1. I to the first power is the square root of -1. I squared is -1. And I cubed is negative square root of -1. If an exponent is bigger than 3, we'll use long division and use the remainder to find our answer. We have a 67 here. Let's divide that by 4. 4 goes to 6 one time. Get 2. 4 goes to 27 6 times. Our remainder is 3. Now when we're identifying what I to some power is, we don't care what the whole number is. All we care about is the remainder. So I to the 67th power equals I to the third power because it just loops over and over and over forever. After I cubed comes I to the 0th again. So that means I to the 4th power is the same as I to the 0th power. If you keep cycling it through, you'll get a 67 right here. That's equal to negative square root of -1. A complex number has both real and imaginary parts. On page 18, we use conjugates to rationalize denominators. So whenever you have a denominator, you don't want anything that's more than needed in the denominator. You only want whole numbers if possible. So let's say what the conjugates are. The conjugate of -8i plus 1 is just 8i plus 1. Basically, we change the sign of whatever number is in front of the I or square root. 4i plus 3, we change that sign to a minus, so we have -4i plus 3. Notice we don't change the real part, we only change the imaginary part. 6 plus 5i, we have 6 minus 5i. And we use a similar trick with irrational numbers. So change the sign in front of the irrational number. So to rationalize a denominator, you just multiply the numerator and the denominator by the conjugate. Basically, you're doing a sum of squares. If you multiply that out, you get 3 squared minus 7i squared at the bottom, and then at the top you have 3 minus 7i. If you multiply that out, you get 3 minus 7i over 9 plus 49. And your simplified form, your rationalized fraction would be 3 minus 7i all over 58. Okay, enough imaginary numbers for now. We're writing the equations given the zeros. So if x equals 2 and 3, so we write some parentheses, put x, instead of +2, put a -2. We change the signs of each of our zeros. X minus square root of 5 plus square root of 5. One thing about irrational numbers that have square roots and imaginary numbers is that it can't have one without the other. It has to have plus and minus here. So for this one, our factors would be x minus square root of 7 and x plus square root of 7. It would have both, not just the one that's listed there. Same thing with the 4i. We'd have x minus 4i and x plus 4i. Let's look at page 20. We're determining the number of real roots and imaginary roots. Given the number of complex and a graph. So if we have two complex numbers we know that there's one that crosses right here and one that crosses right here. That's two. Two reals. Two that you can see here. There's only two. 2 minus 2 is 0, so there's no imaginaries here. What if there's two complex here? Well, it never crosses the x-axis, so there's no reals. But there's two complex, so there must be two left. 2 minus 0 is 2, so there's two imaginary. And then this one, if there's 7 complex, we don't know exactly how many there could be, but we know that there's 5 to 7 here. 5 to 7 real, and that means there must be 0 to 2 imaginary. Now, if you look at these 4 pictures, these are the 4 different kinds of things you'll find on a graph to determine if it's real or imaginary. This first one has 0 real. It never crosses the x-axis, so it can't have any real solutions. This one we know has 1 repeated real. And this one right here has 2 reals. And the last one right here, it looks like a cubic kind of function. It has 3 repeated reals. It's also a inflection point. So just by looking at those pictures, these graphs, we know that information about each of them. That's how we could go back to this one. We know it's 5 to 7 reals. It's 3 right here. There's 2 right here, so there's at least 5. But who knows, maybe there was 4 repeated here instead of 2. That could be a possibility. Page 21, Vertex Formula. Here is the vertex formula. If you don't have a calculator, this is very useful. Negative b over 2a, comma, f of negative b over 2a. So basically this is h and this is k. You plug in the h value to get k. So what we want to do here is first identify a, b, and c. A is 3, b is negative 6, and c is 5. We actually don't need to know c, but we can label it anyway. Let's go ahead and find h, which is equal to negative b over 2a. So we have negative, parentheses, negative 6, all over 2 times 3. That equals 1. We'll plug that in to find k. And if you put that in, if you work it out, you should get 2. So your vertex is 1, 2. So using the vertex, we can write our vertex form equation. So f of x equals a, which is 3, parentheses x minus h, which is 1, squared, plus k, which is 2. That's our formula. And this is our vertex. Let's look at page 22. We're completing the square to convert to vertex form. What you want to do first is move the c over to the other side. And let's just set this to 0 for just a moment. So we have x squared minus 12x equals negative 23. Let's add b over 2 squared, like on page 11. That would be negative 6 squared. So we'll add 36 to each side. So x squared minus 12x plus 36 equals 13. We will factor. If we factor, we get x minus 6 squared equals 13. Take the square root of both sides to get rid of the square. We have a plus or minus. Now, that would be to solve it, but we only want the vertex form. So from here, we just add the 13 back to the other side and put f of x back. So our vertex form would be x minus 6 squared minus 13 equals f of x. At the bottom of the page, we have two graphs. Neither are quadratic. These are to locate maxes and mins. On this graph, so we have three maxes altogether on both of these graphs. So we have a max right here, we have a max right here, and we have a max right here. Now this max is at the very, very top. That is considered an absolute max, or ABS max. Any other max is just called a relative max, or just a maximum. Same thing for minimums. This is a minimum, this is a minimum, and this is a minimum. Now which one is the absolute minimum? It's this one, it's the lowest one. This was not absolute minimum because there's arrows that keep going down. Page 23, we're going to go from vertex to standard. So first we want to expand our binomial that is repeated here. Now you could use any method, FOIL or box. We're using FOIL right now though. So I have 3 parentheses x times x, which is x squared. O is x times -1 is -1x. Outer, -1x. And the inner, plus 1. Close parentheses, plus 4. Combine the like terms, you get -2x. So we have 3 parentheses x squared minus 2x plus 1 plus 4. The next step you want to do is distribute that 3 in. Multiply each term by 3. We have 3x squared minus 6x plus 3 plus 4. The last step, you will add these two constants together. So your standard form is 3x squared minus 6x plus 7. So here's our verbal steps. We first expand x minus 1 squared. Step 2, we multiply the two binomials together. Step 3, we combine the x terms. Step 4, we distribute the 3 into each term on the inside. And the last step, we combine the two constant-like terms. Page 24, we're going from factored to vertex. So if we already have it in factored form, we're going to find h. We add the two roots together and get the average. That's h. To get k, you just plug in h into the x's to evaluate k. A only affects the k, it does not affect the h. Let's look at that on this example. Y equals 1, parentheses x minus 3, x plus 1. Let's identify our A, our H, and our K. A is 1 because we have a 1 right here. R1 is 3, and R2 is -1. It's the opposite signs. Let's plug it into that formula. H equals R1, which is 3, plus R2, which is -1, all over 2. That equals 2 over 2. 2 divided by 2 equals 1. So H equals 1. To find K, just plug it into the equation. 1, parentheses 1 minus 3, parentheses 1 plus 1. If you evaluate that, you get -4. So K equals -4. To find your vertex equation, we just put it into the formula. f of x equals, and recall from page 21 the vertex formula, for the vertex form equation, not vertex formula. We have a, which is 1, parentheses, x minus h plus k, so put minus 4. And that's our vertex form equation. Page 25. Now we're going to talk about characteristics of quadratics. So this right here is a quadratic. The shape is a parabola. It's two complex numbers in a quadratic. In this case, there's two real because it crosses the x-axis 2 times. That means there's 0 imaginary. It's neither even nor odd because it's not symmetric with the y-axis and it's not symmetric with the origin. It's concave up because if you look at the picture, it looks like a smiley face. We would call that concave up, and we'll talk more about that on page 31. The eccentricity of all parabolas is 1, and the transformations on this one is right 1 and down 4. And the inverse, by the way, would be the square root of x plus 4 plus 1. And that could either be a plus or a minus, so there's really two functions together. Now notice on your copy of the notes, you should have letters labeled A, B, C, and so on. Okay, so for each of these, the shape is a parabola. P over Q are possible rational numbers. It would be plus or minus 3 and plus or minus 1. Now A is the axis of symmetry. That's that red line, that's a vertical line going up and down. If you were to fold along that line, the two blue sides of the graph would be symmetrical. B are the roots. These are your solutions. These are your real zeros. The x-intercepts. C is your y-intercept. That's where it crosses the y-axis. And that's going to be at 0, negative 3. D is your directrix. That is that dashed line underneath the parabola. E is your end behavior. The end behavior is wanting to know what the range is for the left side to the right side. It's pointing up both times, so it's from positive infinity to positive infinity. F is the focus. It's the same distance from the parabola as the directrix is to the parabola. And you'll learn more about that in pre-cal. G is your vertex. In this case, it's a minimum. If it was a high vertex, it would be a maximum. But this is a low vertex. It's at 1, negative 4. A lot of times when it's asking for maxes and mins, it just wants the y values. It also helps you find the range. The range for this graph would be from negative 4 to infinity. Y is greater than or equal to negative 4. You could also write it in interval notation like this. The domain is all real numbers. And you could also write that in interval notation like this. Negative infinity to positive infinity. But most of the time they'll just say the words all real numbers. It's decreasing right here on this side, on the left side, from negative infinity to 1, and then it's increasing from 1 to infinity on the right side. So the left and the right sides of the vertex, the left side of one is decreasing, and the right side of one is increasing. Now let's talk about checks for symmetry. If you can't see this with just looking at the graph, this is how you can check it algebraically. If f of x equals f of negative x, then that is symmetric with the y-axis. If f of x equals negative f of negative x, then it's symmetric with the origin. And if f of x is equal to negative f of x, then it's symmetric with the x-axis. Which, by the way, those would not be functions. But they could still be parabolas, even if they're not functions. Like if you have parabola facing this way, it would fail the vertical line test, but it'd still be a parabola shape. Page 27, inverses. Inverses are basically the opposites. Here's some examples. The opposite of addition is subtraction. The opposite of division is multiplication. They're inverses of each other. Outside, inside. Horizontal, vertical. Log b x equals y. The opposite of that is b to y equals x. We'll talk more about that one some other time. And then, of course, the opposite of that would just be log x y equals r. And the inverse of y equals square root of x plus 1 plus 3, which the notation for that would be f negative 1x. Then you put equals x minus 3 squared minus 1. The opposite of a square root is a square. The opposite of inside is outside. The opposite of outside is inside. And the opposite of plus is minus. The opposite of plus is minus. There's all your opposites. Page 28. Characteristics of a square root function. So the domain of this is x is greater than or equal to 0, and it's increasing at the same place. X is greater than equal to 0. It's going up the whole time. It's discontinuous. It has domain restrictions. X cannot be less than 0. For the range, y is greater than or equal to 0. Your end behavior, the left side, y is 0, and the right side, y is going to positive infinity. Page 29, we have conic sections. These are all the different types of sections that you could cut on a cone. The only one we'll talk about that much in Algebra 1 is parabolas. Page 30. The general equation is ax squared plus bxy plus cy squared plus fx plus gy plus h equals 0. So for these conic sections, the focus is the point inside the curve. The directrix is the line outside the curve. The eccentricity is the ratio of a curve's distance to the focus and the distance to the directrix. I use these formulas for reference. These will come in very handy when you get to pre-cal. At page 30, page 31, concavity and points of inflection. Concave down is convex up, and concave up is convex down. This is a concave surface, it curves inward. The convex surface bulges outward. Concave is a side that is less than 180 degrees. Convex is a side that is greater than 180 degrees. Concave down. When creating line segments on its graph, they will never be above the graph, as seen in this picture right here. Concave up. When creating line segments on its graph, they will never be below the graph, as seen in this picture right here. Inflex points, where the graph changes from concave up to concave down and vice versa. Quadratic and linear functions do not have it. Cubic does.